Hi scholars, Ms. Perez here again for your next physics lesson. Today we are doing Unit 5, Lesson 13 about wavelength, speed, and frequency of the sound produced by instruments. Today I'm coming to you from this beautiful room that actually is the inside of a guitar. Let's see the strings up there. Alrighty, so let's start our day how we normally do. So first we're going to make sure that we have all the tabs that we need. So you should have your Simplicity to Science website up for Lesson 13, your physics classroom, and then today's classwork document, that's Unit 5, Lesson 13. Okay, let us start with our slides. Okay, again, this is Unit 5, Lesson 13 for wavelength, speed, and frequency produced by instruments. Today you're going to need your notebook, a pen and pencil, and then those 3 tabs that we have opened. The majority of, well, actually all of today's classwork will be done on your Google document. You still need your notebook to take notes of the key points at the end of the lesson. So yesterday, we defined standing waves and how different pitches are created based on the shape of the instrument. Today, we're going to continue our explanation of how the properties of an instrument affect the sound that's produced. Before we dive deep into our lesson, let's start with this do now. Have you ever heard a sound that just doesn't sound good? For example, an instrument that's out of tune? Why do you think that happens? Right, so keep this question in mind while I play this short clip of a man playing the trumpet.
Was it 1 3?
All right, that didn't sound that great. Oops, let's come back to this question. So why do you think that's happening? Why do you think that when we hear that noise, it's just like that sounds kind of almost painful? Also kind of what it sounds like when I try to sing Adele. So when I say press pause now, take the next 2 minutes to write down your ideas. Do this in your classwork document. When you are ready to come back, press play to join us again. Press pause now. Okay, great, welcome back. Ooh, I want to hear that again. So we are going to discuss your thoughts from the do now at the end of this lesson, right? So keep those in mind as we continue on through today's class. So we have this new important vocabulary word that's going to be defined in today's reading. Harmonics, or sometimes referred as harmonic frequency. Keep an eye out for it as you're reading. We're going to define it at the end of, you have to define it at the end of class. So when you see it in your reading, make sure that you annotate for that. This principle of harmonics is at the core of today's lesson. Okay, so the bulk of today's class will be reading and annotating. So you're going to take the next 10 minutes to read, annotate, and make notes of the reading in the classwork documents. Right, keep these guiding questions in mind. How does the speed, frequency of wavelength relate in the instruments? Does the shape of an instrument affect the frequency of the sound produced? What are harmonics and how does that relate to the speed of sound of an instrument? And what equation can be used to predict the wavelength in an open tube or in a closed tube? So you don't have to answer these questions explicitly, but they will help us answer the check for understanding at the end of class. These guiding questions are also listed in your classroom to help you with your annotations for the reading. Right, so when I say press pause now, take the next 10 to 15 minutes to read and annotate these questions. When you're ready to come back, press play to join us. Press pause now. Okay, welcome back, scholars. So we have a few important key points from the reading. So first, harmonic frequencies or harmonics are specific frequencies of vibration in which an instrument that produces a standing wave. And so that's why it was important for us yesterday to define what a standing wave was so that we can understand what a harmonic frequency is. When an instrument vibrates at a frequency that's not a harmonic, it won't produce a standing wave pattern. And it's going to sound terrible, just like the trumpet player from Arduino, right? Or when we sing off key or something, that's the same idea. Okay, while I'm reading out these key points, you should be taking these, writing these down in your notebook. If you need time to write them all down, press pause to make sure that you get them all. All right, so we have a few more key points here. Going to move myself over here. So sound, another key point is that sound is produced by a standing wave in the column of air. So for a tube that has open on both ends, each harmonic will have an antinode at each end. For a tube open at one end, each harmonic will have an antinode and a node at the other. So the drawings for this were in your reading, and this also connects to what we were talking about yesterday in the video that we saw with Bozeman Science. Like, he went into depth about this particular key point. The length of a tube is half a wavelength for an open tube and a quarter of a wavelength for a closed tube at one end. And so that might sound a little confusing, but again, you can refer to the images in your reading to help you understand this key point if you need to. And then the last point is to change the pitch heard from a tube. Either change the length of the tube or close the tube at the end. Right? That is why in flutes, there's all those little holes, like flutes, saxophones, any wind instrument, there's tons of different keys, because by pressing the keys, you're in a sense kind of changing the length of a tube. So that's what causes all the different notes to sound in an instrument. Okay, so again, if you need time to write these down, press pause so you can put them all into your notebook. Okay, this last slide here is a summary for us of the different modes of vibrating of standing waves. So basically, these are all the different harmonics. This is if you have a string, like a guitar, you have two nodes on either side because it's closed. And then a closed pipe over here, you have a node on the closed end and then an antinode in the open end. And then for an open pipe, you have antinodes on both sides, right? So then that continues on for all the different harmonics. So you see for the open pipe, doesn't matter what kind of standing frequency is in here, they always have antinodes on the edges. And over here, it tells us this is a first harmonic, second harmonic, third, fourth, and fifth. So for each one of these different harmonics, there's a corresponding equation that relates the wavelength of the standing wave to the length of the pipe itself. This diagram is included in the Simplicity Science website, so you can also refer back to it if need be. Okay. So these three questions will be your check for understanding. These are your exit ticket for today's class. You need to define harmonics and then state the relationship between the length of an instrument and the pitch produced, and then also explain how we can predict the harmonic frequencies of each type of instrument. Okay, you are going to take the remaining of this class to answer those three questions in your classwork documents. Once you're completed, you can upload this into your Google Classroom. If you have any questions, you can ask your teacher as soon as this video is over. Okay. That's all for me. I hope you all have a wonderful day.